Picture a world where the oceans stretched endlessly, unbroken by continents as we know them today, and the air was thick with the scent of salt and the promise of life. This was Earth, tens of millions of years ago, long before the first human footprints would ever mark the sand. The planet's surface was dominated by vast primeval seas, uncharted, mysterious and teeming with life forms that would seem alien to us now. These ancient oceans were bustling ecosystems, home to a dazzling array of marine giants and formidable predators. From armoured fish to swift marine reptiles, every niche was filled by creatures perfectly adapted to their environment, each playing a role in the intricate web of prehistoric life. Amidst this vibrant chaos, one animal stood out as the undisputed apex predator, a hunter so powerful and so perfectly engineered for dominance that it reigned supreme over all others. This was the Megalodon, a shark of such staggering proportions and strength that its very name has become synonymous with prehistoric power. Estimates suggest that adult megalodons could reach lengths of up to 60 feet, making them 3 times longer than the largest great white sharks alive today. For nearly 20 million years, from the Miocene through the Pliocene epochs, Megalodon thrived in the warm, shallow seas that covered much of the globe. These epochs were periods of dramatic change, with continents drifting, climates shifting, and new forms of life emerging both in the oceans and on land. Megalodon's reign was marked by its extraordinary success as a predator. Its massive body, powerful tail, and keen senses allowed it to hunt with unmatched efficiency, preying on whales, large fish, and other marine mammals. Its presence shaped the very structure of ancient marine ecosystems. To understand Megalodon is to embark on a journey through deep time to an Earth that was wilder, more volatile, and infinitely more mysterious than the world we know today. The planet's surface was in constant flux, with rising and falling sea levels creating new habitats and opportunities for evolution. Long before the dramatic extinction of the dinosaurs, the ancestors of sharks had already established themselves as masters of the sea. These early cartilaginous fish were among the first vertebrates to develop jaws, a revolutionary adaptation that set the stage for the rise of true sharks. Sharks as a lineage are among the oldest surviving vertebrates on Earth, with a fossil record stretching back over 400 million years. They have witnessed the rise and fall of countless other species, adapting and evolving through every major extinction event. These remarkable survivors swam the oceans before the first trees took root on land, and they endured cataclysms that wiped out nearly all other forms of life. Their resilience is a testament to the power of adaptation and the relentless drive of evolution. The Megalodon itself, however, was a relatively recent arrival, appearing around 23 million years ago. It was the culmination of millions of years of evolutionary refinement, a predator built for the apex position in a world of giants. Unlike the dinosaurs, Megalodon did not share its world with Tyrannosaurus rex or Triceratops. Instead, it lived in an era dominated by mammals, both on land and in the sea. The oceans were filled with enormous whales, dolphins, and other marine mammals, providing a rich hunting ground for this super predator. Megalodon's hunting strategy was as impressive as its size. With jaws capable of exerting a bite force estimated at over 40,000 pounds, it could crush the bones of even the largest whales. Its teeth, some over 7 inches long, were perfectly designed for slicing through flesh and bone, making it the ultimate marine predator. The very name Megalodon comes from the Greek words for giant tooth, a fitting tribute to the most iconic feature of this ancient shark. These teeth are among the largest ever discovered, and their unique shape and serrations reveal much about the animal's feeding habits and evolutionary history. For centuries, these fossilized teeth were the only evidence of Megalodon's existence. Their sheer size and abundance in certain fossil beds have allowed scientists to reconstruct the life and times of this extraordinary predator in remarkable detail. In ancient times, these mysterious triangular stones were often mistaken for the tongues of dragons or the petrified remains of mythical creatures. It was only with the advent of modern science that their true origin was revealed. Today, paleontologists use these teeth to unlock secrets about Megalodon's biology, growth rates, and even its migratory patterns. By comparing them to the teeth of modern sharks, researchers can estimate the size, age, and even the diet of individual megalodons. These fossilized teeth tell a story of a predator unlike any alive today, a creature whose power and presence have captured the imagination of scientists and the public alike. The megalodon's legacy endures not just in legend, but in the very rocks beneath our feet. By studying Megalodon, scientists gain invaluable insights into the history of our oceans and the extraordinary creatures that once inhabited them. Each new discovery adds another piece to the puzzle of Earth's ancient past. The story of Megalodon is a testament to the power of evolution, demonstrating how life can adapt and diversify to fill every available niche. It reminds us that the oceans have always been a stage for giants, and that the history of life is one of constant change and renewal. The tale of Megalodon is more than just the chronicle of a giant shark. It is a window into a vanished world, a world where the boundaries of possibility were constantly being redrawn by the forces of nature. The extinction of Megalodon serves as a powerful reminder of the fragility of even the most dominant species. As the climate cooled and ocean ecosystems changed, this mighty predator vanished, leaving only its teeth as silent witnesses to its former glory. As we continue to explore the depths of our oceans, we uncover not only the secrets of Megalodon, but also the ongoing story of life on Earth, a story of adaptation, survival, and the endless mystery that still lies hidden beneath the waves. When we try to picture the Megalodon, it's tempting to imagine a supersized version of the great white shark gliding through the ancient seas. But the reality, as revealed by years of scientific research, is far more fascinating and complex. While Megalodon was indeed a shark, its appearance set it apart from any living species. Recent studies of fossilized remains have revealed a creature with a robust torpedo-shaped body built for power and endurance. Its head was massive, with a shorter, blunter snout than the great white, and a jaw that was not only wider but also flatter, designed to deliver devastating bites. The Megalodon's jaw was a marvel of evolution, capable of opening wide enough to engulf prey whole, and lined with rows of serrated teeth, each as large as a human hand. Its most distinguishing features, aside from its sheer size, were its incredibly long pectoral fins. These fins, stretching out like the wings of a jet, helped stabilize and steer its enormous body through the water. These oversized fins were essential for balance, acting like the rudders of a submarine, allowing Megalodon to make surprisingly agile turns despite its bulk. To truly grasp its size, imagine a creature stretching up to 65 feet, about the length of 2 city buses parked end to end, and weighing as much as 50 tons, more than 10 adult elephants combined. In the vastness of the ancient oceans, Megalodon was a true leviathan, its presence dominating the seascape and casting a shadow over everything beneath it. The sheer scale of Megalodon is almost beyond comprehension. Its mouth alone could span nearly 3 meters across, and its teeth were the largest of any known shark species. Scientists have painstakingly reconstructed its size from these fossilized teeth and vertebrae, using mathematical models to estimate that an average adult Megalodon could reach lengths of 60 to 70 feet, with some outliers possibly even larger. Interestingly, females were likely much larger than males, sometimes nearly twice the size, a trait still seen in many modern shark species where larger females can carry more offspring. With a body this enormous, Megalodon's appetite was nothing short of legendary. It needed to consume vast quantities of food just to maintain its energy and mass. Scientists estimate that a single adult megalodon would have needed to eat over 2,500 pounds of food every day, roughly the weight of a small car. That's the equivalent of devouring an entire cow every single day, a relentless quest for calories to fuel its powerful muscles and constant movement. So what could possibly satisfy such a colossal appetite? The answer lies in the rich diversity of the ancient oceans, teeming with massive marine mammals and large fish. Megalodon was the ultimate apex predator, reigning at the very top of the food chain with no natural enemies, its dominance shaping the entire ecosystem. Its primary prey were the early baleen whales, giant, slow-moving mammals that provided the perfect high-calorie meal for a hungry megalodon. These whales, some nearly as large as the megalodon itself, were hunted with precision and power, their size no match for the shark's crushing bite. Megalodon's hunting strategy was both brutal and efficient. It likely targeted the fins of its prey, crippling them before delivering a final bone-crushing bite. With jaws capable of exerting a bite force of over 40,000 pounds per square inch, stronger than any known animal, Megalodon could shatter bones and tear through flesh with ease. The presence of such a giant predator would have shaped the entire marine ecosystem, influencing the behavior, migration and evolution of countless other species. As the top predator, Megalodon controlled populations of other large animals, driving evolutionary arms races and shaping the very structure of ancient marine life. The mere shadow of Megalodon gliding overhead would have sent waves of panic through the ocean, causing entire schools of fish and even other sharks to scatter in terror. Its jaw was so enormous, estimated at nearly 3 meters wide and over 3 meters tall, that it could have easily swallowed 2 adult dolphins side by side in a single gulp. Megalodon was not just a giant fish, it was a force of nature, a living mountain of muscle and teeth that ruled the ancient oceans for millions of years, unmatched in power, size and ferocity. Its legacy endures in the fossilized remains that continue to awe and inspire us, a reminder of the incredible creatures that once dominated our planet's waters. The Megalodon, one of the largest and most formidable predators in Earth's history, was not confined to a single region or habitat. Instead, it was a true global inhabitant of the prehistoric seas, thriving during the Miocene and Pliocene epochs, roughly 23 to 3.6 million years ago. During this time, the world's oceans were vastly different from today, with higher sea levels, warmer global temperatures, and extensive shallow continental shelves that created a mosaic of diverse marine environments. Fossilized megalodon teeth have been unearthed on every continent except Antarctica, providing compelling evidence of its extraordinary range. These discoveries span from the Atlantic and Pacific coasts of North and South America to the shores of Europe, Africa, Asia and Australia, painting a picture of a species that dominated nearly every major oceanic region. Megalodon's presence has been confirmed in the frigid waters off Denmark, the temperate seas surrounding New Zealand, and the balmy coasts of South America and Africa. This wide distribution demonstrates not only its adaptability, but also the interconnectedness of ancient marine ecosystems, where ocean currents and shifting land masses allowed for extensive migration and gene flow. Megalodon thrived in a variety of marine habitats, from deep pelagic zones to shallow coastal waters, continental shelves, and even ancient estuaries. Its ability to exploit such a range of environments was a key factor in its evolutionary success, allowing it to hunt a diverse array of prey and avoid competition with other large predators. However, despite its adaptability, Megalodon showed a marked preference for certain conditions. The fossil record and isotopic analysis of Megalodon teeth indicate a strong affinity for warm, tropical and subtropical waters. These regions, characterized by stable temperatures and abundant marine life, provided ideal conditions for both hunting and reproduction. The warm currents of the Miocene and Pliocene oceans, such as the ancient Tethys Sea and the Proto-Gulf Stream, likely served as major highways for megalodon migration. Adult megalodons were capable of traversing vast stretches of open ocean in pursuit of large prey, such as early whales and giant fish. Yet they also frequented coastal regions, where upwelling currents brought nutrient-rich waters and supported dense populations of marine mammals and fish. These coastal zones, with their abundance of prey and complex habitats, were critical hunting grounds for Megalodon. Here it could exploit seasonal migrations of whales and other large marine animals, as well as target schools of fish and smaller sharks. Paleontologists have identified several ancient nursery sites, including those in Panama, Maryland, the Canary Islands and Florida. These locations were characterized by shallow, protected waters, ideal for the growth and survival of juvenile megalodons. These nurseries offered shelter from larger predators and a plentiful supply of smaller fish and invertebrates, allowing young megalodons to grow rapidly before venturing into deeper waters. The existence of such specialized habitats suggests complex life history strategies and a high degree of ecological sophistication. Notably, the only continent where megalodon fossils have not been found is Antarctica. This absence is not merely a gap in the fossil record, but a significant clue about the species' environmental limitations. The lack of megalodon remains in Antarctica suggests that the cold, nutrient-poor waters of the Southern Ocean were inhospitable to this warm-blooded predator. Even during the warmest periods of the Miocene, the Antarctic region remained too cold and isolated for Megalodon to colonize. Megalodon's reign coincided with a time when Earth's climate was generally warmer than today, with polar ice caps much smaller or absent, and tropical conditions extending farther from the equator. However, even in this greenhouse world, Megalodon remained a creature of warmth, avoiding the coldest extremes. The frigid, ice-laden waters of the polar regions presented insurmountable physiological challenges. Megalodon's metabolism, adapted for warm seas, would have struggled in such cold environments, and the scarcity of suitable prey further limited its ability to survive there. The Antarctic Ocean, with its extreme cold and unique ecosystem, remained beyond the reach of Megalodon, shaping the boundaries of its global distribution. As the planet's climate began to cool during the late Pliocene, ocean temperatures dropped, polar ice expanded, and the warm water corridors that Megalodon depended on began to vanish. This dramatic shift in climate and oceanography played a pivotal role in the species' eventual extinction. The global distribution of Megalodon fossils, from the Atlantic to the Pacific and Indian Oceans, tells the story of a predator that once ruled the seas, adapting to a wide array of habitats and climates until the world changed beyond its ability to adapt. For millions of years, Megalodon patrolled the coastlines, continental shelves, and open waters of the world's great oceans, shaping marine ecosystems and influencing the evolution of countless other species. Its presence was a constant force in the ancient seas, driving evolutionary arms races and maintaining the balance of marine life. By studying the distribution and context of Megalodon fossils, scientists are able to reconstruct not only the shark's size and diet, but also the intricate web of ancient habitats it once inhabited, from shallow nurseries to the vast open ocean. The widespread discovery of Megalodon remains across the globe stands as a testament to its dominance and adaptability. offering a window into the dynamic, ever-changing world of Earth's ancient oceans, a world where Megalodon was once the undisputed apex predator. The most iconic feature of the Megalodon is, without question, its teeth. Massive relics that have captivated scientists and enthusiasts alike for generations. These teeth are not only the source of the shark's name, but also the key to unlocking the mysteries of its biology, behavior and dominance in ancient oceans. Unlike the teeth of any modern shark, Megalodon's teeth were colossal, with some specimens exceeding 7 inches in length. Their sheer size dwarfs even the largest teeth of today's great white sharks, providing a glimpse into the scale of this prehistoric predator. Each tooth was not only long, but also remarkably wide and thick, engineered to withstand the tremendous forces generated during feeding. The robust structure of the tooth root anchored it firmly within the jaw, while the crown was built to resist fracturing under pressure. The internal structure of a megalodon tooth reveals a sophisticated design. A thick layer of enamel protected the tooth from wear, while the underlying dentin provided resilience and shock absorption. This combination allowed the teeth to remain effective even after repeated impacts with bone and blubber. Megalodon's teeth were shaped like broad triangular blades, wide at the base for stability and tapering to a razor-sharp point. This geometry maximized the surface area for cutting, making each bite devastatingly efficient. The edges of these teeth were lined with fine saw-like serrations. These micro-serrations functioned much like the teeth of a modern steak knife, enabling Megalodon to slice cleanly through thick whale hide, dense blubber, and even the bones of its prey. The jaws of Megalodon housed an astonishing 276 teeth, arranged in 5 distinct rows. This configuration ensured that the shark always had a formidable arsenal ready for action, with new teeth constantly moving forward to replace those lost or damaged. This conveyor belt system is a marvel of evolutionary engineering. As teeth in the front row were shed or broken, new teeth from the rows behind would rapidly move forward, ensuring that Megalodon never lost its predatory edge. Incredibly, a new tooth could be ready to take its place in as little as 24 to 48 hours. This rapid replacement rate meant that Megalodon's bite was always at peak performance, no matter how intense the hunt. Over its lifetime, a single Megalodon could produce tens of thousands of teeth. These teeth, scattered across ancient seabeds, are among the most common and scientifically valuable shark fossils ever discovered. The power behind these teeth was nothing short of extraordinary. Using advanced computer models, scientists have estimated that Megalodon's bite force ranged from 10 to 18 tons, far surpassing any living shark and even the mighty Tyrannosaurus rex. To put this in perspective, Megalodon's bite was more than 10 times stronger than that of a great white shark, and nearly 3 times greater than a T-Rex. This immense force could easily crush the ribcage of a whale, shattering bone and causing catastrophic internal damage with a single bite. Fossil evidence supports this, with ancient whale bones bearing unmistakable Megalodon bite marks, deep gouges and punctures that testify to the shark's overwhelming power and predatory strategy. This combination of massive serrated teeth and an unparalleled bite force made Megalodon the undisputed apex predator of its era. No other marine animal could rival its hunting capabilities or its dominance in the food chain. In the vast ancient oceans, Megalodon reigned supreme, its presence alone shaping the evolution and behavior of countless marine species. Scientists believe Megalodon's hunting strategy involved using its immense bulk and speed to ram prey, followed by a crippling bite to immobilize large animals such as whales, ensuring they could not escape. Once the prey was incapacitated, Megalodon could feed at its leisure, using its formidable teeth to tear through flesh and bone with ease. Today, the fossilized teeth of Megalodon are more than just remnants of a long-extinct predator. They are scientific treasures, windows into the anatomy, ecology, and evolutionary success of one of the most formidable hunters the world has ever known. Each tooth stands as a testament to the power, adaptability, and enduring mystery of the ocean's ultimate apex predator. For millions of years, Megalodon reigned as the apex predator of the world's oceans, its massive jaws and unparalleled strength making it virtually untouchable. Yet, even the most dominant species can be brought down by the relentless forces of nature and time. The question of why Megalodon vanished has fascinated paleontologists, marine biologists and geologists for decades, sparking a multitude of scientific investigations and debates. Around 3.6 million years ago, Megalodon abruptly disappeared from the fossil record. This sudden absence is not just a gap in our knowledge, it marks the extinction of one of the most formidable predators to ever exist. So what could have caused the downfall of such a dominant species? Scientists have proposed several interlocking theories, each supported by a growing body of evidence and expert analysis. The most widely accepted explanation centers on dramatic climate change during the Pliocene epoch. According to Dr. Catalina Pimiento, a leading megalodon researcher, the extinction was likely driven by a combination of environmental shifts that occurred too rapidly for the species to adapt. One of the primary culprits was a significant drop in global temperatures. As the Earth cooled, oceanic conditions changed dramatically, especially in the temperate and subtropical regions where Megalodon thrived. During the Pliocene, the formation of massive polar ice caps led to a cooler planet. This shift is well documented in sediment cores and isotopic analysis, which reveal a steady decline in ocean temperatures. As a result, the warm, shallow seas that Megalodon depended on began to contract. The species, adapted for warmer waters, found its preferred habitats shrinking year by year. The reduction of these warm water environments is supported by fossil evidence, which shows a marked decline in Megalodon remains in higher latitudes as the climate cooled. Another devastating consequence of global cooling was the drop in sea levels. As more water became trapped in expanding ice caps, vast stretches of shallow coastal waters, critical for Megalodon nurseries, vanished. These shallow, protected bays were essential for the survival of Megalodon pups, providing shelter from larger predators and abundant food sources. Without these nurseries, juvenile Megalodons would have faced increased predation and competition, making it far more difficult for them to reach adulthood. The loss of these safe havens is considered by many experts, including Dr. Kenshu Shimada, to be a critical factor in the species' decline, as it directly impacted their reproductive success and population stability. Over thousands of years, this led to a slow but inexorable decrease in Megalodon numbers as fewer young survived to adulthood. Simultaneously, the Megalodon's food supply was also under threat. The same environmental changes that affected the sharks also disrupted the populations of large marine mammals, especially baleen whales, which were Megalodon's primary prey. As ocean temperatures dropped, many whale species either went extinct or migrated toward the newly forming polar regions, far beyond the reach of the warm water-adapted Megalodon. This migration and extinction of prey species is well documented in the fossil record and is supported by isotopic analysis of ancient whale bones, which show a shift in their habitats. With less food available, Megalodon would have faced starvation, especially given its enormous size and energy requirements. Adding to these challenges, new and more agile predators began to emerge. The ancestors of modern great white sharks and large predatory whales, such as orcas, were better suited to the cooler, changing oceans. These competitors not only outcompeted Megalodon for the remaining food sources, but may have also preyed on its young, further accelerating its decline. Fossil evidence of bite marks on ancient whale bones suggests intense competition for food during this period. Beyond environmental and ecological factors, some researchers have proposed more extraordinary theories. One such hypothesis suggests that an astronomical event, a nearby supernova, may have played a role in Megalodon's extinction. About 2.6 million years ago, a star exploded in a supernova roughly 150 light-years from Earth. According to astrophysicist Dr. Adrian Mellott, this event would have bathed our planet in a surge of cosmic radiation. The resulting increase in radiation could have had profound effects on large marine animals, especially those like Megalodon, that spent much of their lives near the ocean's surface. For a massive animal weighing over 60 tons, increased exposure to cosmic rays could have led to higher rates of cancer and genetic mutations, further weakening an already vulnerable population. While this theory remains controversial, it is supported by recent studies on the effects of cosmic radiation on marine life. In summary, the extinction of Megalodon was almost certainly the result of a complex interplay of factors: rapid climate change, loss of nursery habitats, dwindling prey populations, increased competition, and possibly even cosmic radiation. Each theory is supported by a unique set of evidence, and together they paint a picture of a species caught in the crosshairs of a rapidly changing planet. As new discoveries are made and technology advances, our understanding of Megalodon's mysterious disappearance continues to evolve, offering fresh insights into the fragility of even the mightiest creatures on Earth. Long before humans ever set foot on land, the ancient oceans teemed with life forms of staggering proportions. While Megalodon was certainly the largest predatory shark to ever exist, it was far from alone in the realm of giants that ruled these primeval waters. The prehistoric seas were a dynamic, ever-changing ecosystem, where titans from different lineages competed, hunted, and sometimes even crossed paths in the struggle for survival. The history of our planet is filled with incredible marine creatures of immense size, some of which were reptiles, not fish. These ancient oceans were not just home to sharks, but also to colossal marine reptiles and enormous bony fish, each adapted to their own ecological niche. One such formidable neighbour was the Mosasaurus, a massive marine lizard that lived during the time of the dinosaurs, about 66 million years ago, long before Megalodon appeared. The Mosasaurus was not a fish, but a reptile, and it dominated the Cretaceous seas with its sheer size and predatory prowess. The Mosasaurus was a dominant predator of its era, growing to over 50 feet long. Its presence alone could send smaller marine creatures scattering for cover among the reefs and rocky outcrops. It had a long, crocodile-like head filled with 2 rows of razor-sharp teeth on each jaw, and even had extra teeth on the roof of its mouth to ensure its prey could not escape. This unique dental arrangement made Mosasaurus a relentless hunter, capable of seizing slippery prey with ease. It was a powerful hunter that ruled the Cretaceous seas, often preying on fish, turtles, and even other marine reptiles. The Mosasaurus was an apex predator, shaping the ecosystem by keeping populations of other large animals in check. Even larger than the Mosasaurus was a group of marine reptiles known as ichthyosaurs. These remarkable creatures, with their streamlined, dolphin-like bodies, were not related to dolphins at all, but evolved similar shapes through convergent evolution to thrive in the open ocean. The largest known marine reptile of all time was a type of giant ichthyosaur called Shastasaurus, which lived around 210 million years ago. Shastasaurus was a gentle behemoth peacefully traversing the Triassic seas. This creature could reach a staggering 69 feet in length and weighed over 75 tons. Its immense size made it one of the largest animals to ever inhabit the oceans, rivaling even the modern blue whale. Despite its enormous size, Shastasaurus was a gentle giant, feeding mostly on small fish and squid, much like a modern whale shark. Its feeding habits shaped the ecosystem, as it filtered vast quantities of small organisms from the water, helping to maintain the balance of marine life. A more recently discovered relative, named Ichthyotitan severnensis, found in England, might have been even bigger, possibly reaching lengths of 85 feet or more. This colossal reptile would have been one of the largest marine animals ever recorded, its presence altering the very dynamics of the ancient food web. These different giants show that the ocean has produced massive creatures through various evolutionary paths. Each lineage, sharks, reptiles and fish, developed unique adaptations to survive and thrive in the ever-changing marine environment. Megalodon was a shark, with a skeleton made of cartilage, giving it both strength and flexibility to pursue fast-moving prey across vast distances. Mosasaurus was a reptile, related to snakes and lizards, that had adapted to a fully aquatic life. Its limbs transformed into powerful flippers, and its tail became a strong, paddle-like appendage for swift movement. Ichthyosaurs were another distinct group of reptiles that had evolved a fish-like body shape through convergent evolution. They even gave birth to live young, a rare trait among reptiles, allowing them to spend their entire lives at sea. Each of these giants was perfectly suited to its own time and environment. Their bodies, behaviours and diets were shaped by the challenges and opportunities of their ancient worlds. The Mosasaurus dominated the late Cretaceous seas, preying on turtles, fish, and even other marine reptiles. The Ichthyotitan patrolled the Triassic oceans, filtering vast amounts of small prey from the water. And the Megalodon became the undisputed king of the more recent Miocene and Pliocene epochs, hunting the massive whales of its time with unmatched power. Comparing these giants helps us appreciate the incredible diversity of life our planet has supported. Each species played a vital role in the ancient marine ecosystem, influencing the evolution and survival of countless other organisms. While Megalodon's power came from its immense bite force and predatory nature, other giants, like the Shastasaurus, achieved their size through different means, by filter feeding on small organisms. Sometimes these giants would have shared the same waters, their interactions shaping the balance of power in the ancient seas. Each of these animals tells a unique story about the conditions of the ancient oceans and the evolutionary pressures that led to such extreme sizes. From the nutrient-rich upwellings that supported filter feeders to the vast open waters that challenged predators to grow ever larger, the ancient marine ecosystem was a place of constant change and adaptation. The Megalodon holds a special place as the largest and most powerful predator of its kind. But it is important to remember that it was part of a long lineage of colossal creatures that have called the deep blue sea their home throughout Earth's long and fascinating history. The story of these giants is a testament to the power and mystery of life in the ancient oceans, a world of titans forever hidden beneath the waves. Even in the absence of the Megalodon, the world's oceans remain a stage for some of the most extraordinary and colossal life forms ever to exist. The legacy of giants continues not just in memory but in the living, breathing titans that glide through the deep today. The blue whale, Balænoptera musculus, now holds the record as the largest animal to have ever lived on Earth, surpassing even the mighty Megalodon and the largest dinosaurs in both length and mass. Reaching lengths of up to 105 feet and tipping the scales at nearly 200 tons, the blue whale dwarfs the estimated 60-foot maximum length and 50-ton weight of the largest megalodon specimens. Its anatomy is astonishing. The blue whale's tongue alone can weigh as much as an adult African elephant, and its heart rivals the size of a compact automobile, both far exceeding the proportions of any known megalodon organ. Unlike the apex predator megalodon, which likely preyed on large marine mammals and sharks, the blue whale is a gentle filter feeder, consuming up to 4 tons of tiny krill each day through baleen plates that sieve the ocean's smallest life forms. This evolutionary path highlights a fascinating contrast. While megalodon's size was an adaptation for predation, the blue whale's immense bulk is a product of peaceful grazing, demonstrating that nature's giants can thrive through very different strategies. The shark lineage, too, remains robust and diverse, with over 500 extant species ranging from the minuscule to the massive, each uniquely adapted to their ecological niche. At the smallest end of the spectrum is the dwarf lantern shark, Etmopterus perrier, which measures a mere 8 inches long. Small enough to fit in the palm of a hand, yet equipped with bioluminescent organs for camouflage in the deep sea. At the opposite extreme is the whale shark, Rhynchodon typus, the largest living fish, which can reach lengths of up to 60 feet, comparable to the smaller estimates for megalodon. Despite its size, the whale shark is a docile filter feeder, straining plankton and small fish from the water, a stark contrast to the megalodon's role as a top predator. Like the blue whale, the whale shark's peaceful feeding habits demonstrate that the ocean's giants are not always hunters, but can also be gentle giants, coexisting with smaller marine life. Among modern predatory sharks, the great white Carcharodon carcharias is the most iconic, reaching lengths of up to 20 feet and weighing over 2 tons. Yet even the formidable great white is dwarfed by its ancient relative, the megalodon, which may have been 3 times longer and up to 10 times heavier, with a bite force estimated at over 40,000 pounds per square inch, enough to crush a small car. The fossilized teeth of Megalodon, some over 7 inches long, are a testament to its power and specialization as a hunter of whales and large marine mammals, an ecological role unmatched by any living shark. Modern sharks, however, are evolutionary marvels in their own right, displaying a stunning array of adaptations that have allowed them to survive for over 400 million years. Their skeletons are composed of lightweight, flexible cartilage rather than bone, granting them agility and buoyancy that bony fish and ancient giants like Megalodon could not match. Their skin is armoured with dermal denticles, tiny tooth-like scales that reduce drag and make their hide feel like sandpaper, a feature that inspired the design of modern swimsuits and ship hulls. Sharks possess some of the most acute senses in the animal kingdom. They can detect a single drop of blood in millions of gallons of water, and their sense of smell is up to 10,000 times more sensitive than that of humans. Their hearing is equally impressive, allowing them to pick up low-frequency vibrations from struggling prey over a kilometre away, giving them a predatory edge in the vast dark ocean. Perhaps most remarkable is their ability to sense the faint electrical fields produced by all living creatures, thanks to specialized pores called the ampullae of Lorenzini, located on their snouts. This adaptation enables sharks to locate prey buried beneath sand or hidden in total darkness, making them some of the ocean's most efficient hunters, an ability that even the megalodon likely possessed, though on a much grander scale. These evolutionary tools have allowed sharks to persist through mass extinctions and changing oceans, outlasting even the megalodon. The ocean remains a realm of wonders, teeming with life forms both familiar and bizarre, many of which rival the giants of the past in their own unique ways. The lion's mane jellyfish, for example, boasts tentacles that can extend up to 120 feet, longer than a blue whale or even the largest megalodon. In 2020, scientists discovered a siphonophore in the deep sea, a colonial organism composed of thousands of specialized individuals that measured an astonishing 150 feet in length, making it the longest animal ever recorded. These discoveries remind us that the ocean's capacity for producing giants is far from exhausted, and that new marvels await in its unexplored depths. Even the fossil record continues to yield surprises, revealing ancient leviathans that challenge our understanding of life's upper limits. In 2023, paleontologists announced the discovery of Perucetus colossus, an ancient whale whose estimated mass may have exceeded 300 tons, potentially making it the heaviest animal ever to exist, even surpassing the blue whale and Megalodon. Such findings underscore the ever-evolving story of oceanic giants, both living and extinct, and the scientific quest to understand their biology, ecology, and evolutionary history. From the monstrous megalodon to today's blue whales, whale sharks, and mysterious deep-sea creatures, the ocean remains a domain of giants, a place where the boundaries of size, adaptation, and survival are continually redefined by the forces of evolution and the mysteries yet to be unveiled. The notion that a colossal prehistoric shark, Carcharocles megalodon, might still be lurking in the unexplored abyss of our oceans is a captivating idea that has fueled human curiosity for generations. From the earliest days of seafaring, tales of monstrous sea creatures have haunted the minds of sailors and explorers, their stories echoing through time and inspiring countless legends. In the age of wooden ships, mysterious disappearances and unexplained damage were often attributed to giant sharks, and the megalodon became a symbol of the unknown terrors that might dwell beneath the waves. These legends, passed down through generations, have been woven into the fabric of maritime folklore. The discovery of massive fossilized teeth, some as large as a human hand, only added fuel to the fire. These relics, unearthed from ancient sediments, hinted at a predator of unimaginable size and power, and sparked speculation about whether such a creature could still exist, hidden from modern science. The vastness of the ocean, with over 80% still unmapped and unexplored, has only deepened the mystery. Some believe that the megalodon could have found refuge in the deepest trenches, far beyond the reach of human eyes and technology. Over the years, there have been numerous reports of enormous unidentified creatures spotted by submarines and deep-sea probes. Some sonar readings have revealed shapes far larger than any known shark, fueling speculation and debate among enthusiasts and skeptics alike. Yet despite the allure of these stories, the scientific community has rigorously investigated every claim. Fossil records, sediment analysis and modern tracking technologies have all been employed to search for evidence of the megalodon's survival. One of the most significant scientific arguments against the survival of Megalodon is its dependence on warm, shallow waters. All fossil evidence indicates that this giant shark thrived in tropical and subtropical seas, where food was abundant and temperatures were stable. The deep ocean, often imagined as a possible refuge, is a world of near freezing temperatures, crushing pressure, and scarce resources. No evidence suggests that a warm-blooded predator of megalodon size could adapt to such an environment. Even the most advanced computer models show that a creature of this magnitude would quickly succumb to the cold and lack of food in the deep sea. Its biology was simply not built for the abyss. Instead, Megalodon was perfectly adapted for the warm, food-rich coastal waters of the Pliocene epoch, where it reigned as the apex predator. Today, our oceans are more closely monitored than ever before. Research ships, satellites and underwater drones constantly scan the seas for signs of large marine life. If a population of megalodons still existed, we would expect to find unmistakable evidence. enormous bite marks on whale carcasses, or the remains of prey far too large for any known predator. Yet all the teeth we find are fossils, locked in sediment layers dating back millions of years. Not a single modern tooth, carcass or verifiable sighting has ever been documented. If Megalodon was still alive, we would expect to find fresh teeth washing up on beaches or being caught in fishing nets. But the evidence remains silent. Modern tracking of whale migrations and oceanic movements has revealed no sign of a predator as massive as Megalodon. Such a creature would be impossible to hide in today's interconnected world. The complete absence of physical evidence, no modern teeth, no carcasses, no confirmed sightings, speaks volumes. The only place Megalodon survives is in our stories, our art, and our collective imagination. While the ocean remains a realm of mystery, the overwhelming weight of scientific investigation, fossil records, and modern technology all point to the same conclusion. The reign of the Megalodon ended millions of years ago. Today, it lives on only in the depths of our imagination, a reminder of the ocean's ancient secrets and the enduring power of myth. The story of the Megalodon is not just a tale of a giant predator, but a profound chapter in the evolutionary saga of life on Earth. Its presence in the ancient oceans was a force of nature, shaping marine ecosystems and influencing the very structure of food webs for millions of years. As the undisputed apex predator of its time, Megalodon's immense size and power allowed it to hunt whales, large fish and other sharks, leaving a mark on the evolutionary arms race that drove prey species to adapt and diversify. The memory of Megalodon serves as a humbling reminder of the scale and unpredictability of nature and of the extraordinary creatures that once ruled the seas. Though the Megalodon no longer swims our oceans, its legacy endures in the millions of fossilized teeth scattered across ancient seabeds and coastal cliffs, each one a silent witness to its reign. These fossils are more than relics. They are scientific keys, unlocking secrets about prehistoric ocean temperatures, migration patterns, and the evolutionary history of sharks. The Megalodon stands as an icon of the prehistoric world, its image inspiring generations of scientists, artists, and storytellers. Studying the life and extinction of Megalodon offers invaluable lessons about the delicate balance of life on Earth and the interconnectedness of all species within an ecosystem. The rise and fall of such a dominant species reveals how even the mightiest can be vulnerable to shifts in climate, habitat, and food availability. The cooling of the planet, the formation of polar ice, and the collapse of ancient food chains were forces too great for even this colossal shark to withstand, leading to its eventual extinction. Today, the story of Megalodon echoes in our own era, as we confront the realities of climate change and its profound impact on marine life and global ecosystems. The tale of Megalodon is a cautionary one, reminding us that no species is immune to environmental upheaval and that the health of our oceans demands vigilant stewardship and scientific understanding. Our enduring fascination with Megalodon reflects a deep human curiosity about the unknown, the powerful and the mysterious forces that have shaped our planet's history. We are captivated by stories of giants and monsters, by the idea of a world wilder and more enigmatic than our own, where the boundaries of possibility were constantly being redrawn. The Megalodon embodies this sense of wonder, standing as a symbol of nature's grandeur and the mysteries that still lie beneath the waves. Its story pushes the boundaries of what we believe is possible, inspiring us to keep searching, to dig deeper into the fossil record, and to send our technology into the unexplored depths in pursuit of new discoveries. The quest to understand Megalodon is part of a much larger journey, a journey to comprehend the history of our planet, the evolution of life, and our own place within this vast unfolding narrative. Though the great shark is gone, the ocean remains a realm of endless wonder, filled with life forms both familiar and utterly alien, waiting to be discovered. From the colossal blue whale to the smallest bioluminescent creatures of the abyss, the ocean is a living archive of evolution, with countless species still unknown to science. While Megalodon may be the most famous resident of the ancient seas, its story is but one among many, each chapter revealing new insights into the complexity and resilience of life. The legacy of Megalodon inspires us to gaze upon the oceans with awe and respect, reminding us that we are participants in a story billions of years in the making, a story that continues to unfold in the deep blue heart of our world, where mysteries still await discovery. Beneath the world's oceans and along ancient coastlines, a silent treasure hunt is underway. The search for Megalodon fossils is a meticulous blend of science and adventure, drawing together paleontologists, marine geologists, and fossil hunters from across the globe. Professional divers plunge into murky riverbeds and offshore fossil sites, guided by sonar and underwater drones. Their hands sift through layers of sediment, often uncovering teeth as large as a human hand, each serrated edge still sharp after millions of years. On land, scientists excavate eroding cliffs and ancient seabeds, carefully extracting fossilized vertebrae and jaw fragments embedded in stone. Every discovery is catalogued with precision. In climate-controlled laboratories, researchers analyze the size, growth rings, and chemical composition of megalodon teeth. Microscopic isotopic studies reveal not just the age of the fossils, but also the temperature and chemistry of prehistoric oceans. These data help reconstruct Megalodon's migratory routes, hunting grounds, and even the seasons of its life. Cutting-edge 3D scanning and digital modeling allow scientists to reconstruct entire jaws and visualize the immense bite force of this ancient predator. Computer simulations bring Megalodon back to virtual life, testing hypotheses about its feeding behavior, speed, and ecological impact. Yet the work is far from over. With every new fossil unearthed, the puzzle of Megalodon's life and extinction becomes both clearer and more complex. Each scientific breakthrough opens new questions about the evolution of sharks, the history of Earth's oceans, and the forces that shape life on our planet. The quest to understand Megalodon is a testament to human curiosity and the power of scientific inquiry, a journey that continues to push the boundaries of knowledge, one fossil at a time. Imagine the ancient oceans as a vast living tapestry, teeming with creatures both familiar and alien. At the very top of this prehistoric food web was Megalodon, a predator whose sheer size and power shaped entire ecosystems. But what did it mean to be the ocean's apex hunter? Megalodon's menu was as impressive as its reputation. Fossil evidence reveals bite marks on the bones of giant whales, prehistoric dolphins, and even other sharks. Animation reveals how Megalodon would ambush its prey, using bursts of speed to ram and immobilize massive whales, then delivering bone-crushing bites with its serrated teeth. Its hunting tactics forced marine mammals to adapt, driving the evolution of swifter, deeper-diving species. But Megalodon's influence didn't end with its meals. As a keystone predator, it helped regulate populations of large marine animals, preventing any single species from dominating the ecosystem. This balance allowed diverse communities to thrive, from filter-feeding plankton to agile fish and ancient sea turtles. When Megalodon prowled the seas, its presence sent ripples through every level of the food chain. Visuals shift to dynamic data-driven diagrams, showing the interconnectedness of ancient marine life. Scientists believe that the disappearance of Megalodon may have reshaped the ocean's balance, opening the door for new predators and altering the evolutionary path of whales and sharks that survive today. By studying the fossils and feeding traces left behind, Researchers continue to unravel Megalodon's pivotal role in the prehistoric seas, a role that echoes in the ocean's story long after this giant vanished into legend. Long after Megalodon vanished beneath the waves, its legend has only grown. Today, the shadow of this ancient predator looms large, not just in the fossil record, but across the imagination of millions. Professional, non-repetitive visuals sweep through high-resolution book covers, vintage movie posters and digital renderings from popular documentaries, all showcasing the Megalodon's evolving image. In literature, Megalodon has inspired everything from scientific thrillers to speculative fiction. Authors have reimagined the giant shark as a lurking menace or a misunderstood relic, captivating readers with tales that blur the line between fact and fantasy. Visuals transition to fast-paced montages of best-selling novels and graphic novels, highlighting the diversity of storytelling approaches. On screen, Megalodon's legacy is even more spectacular. Blockbuster films and television specials have brought this prehistoric titan to life with state-of-the-art CGI. Iconic scenes depict the Megalodon breaching the waves or clashing with modern-day sea creatures, images that have cemented its status as a pop culture icon. The narrative pauses over dynamic sequences of animated sharks swimming through digitally rendered cityscapes and deep-sea expeditions, underscoring the Megalodon's enduring appeal. Even in the world of gaming and virtual reality, Megalodon remains a favourite adversary. From immersive underwater adventures to educational simulations, creators harness the shark's mystique to challenge, thrill, and teach new generations. Professional visuals display sleek user interfaces and in-game footage, emphasising the shark's adaptability as a modern myth. Why does Megalodon continue to fascinate? Perhaps it's the blend of scientific mystery and untamed power, a reminder of nature's ability to inspire awe even millions of years after extinction. As science uncovers new facts and storytellers spin new legends, Megalodon's influence only grows, bridging the ancient and the modern, the real and the imagined. In the end, the Megalodon is more than a fossil. It's a phenomenon, one that continues to ripple through our culture, challenging us to imagine what lurks beyond the edge of the known.